We've previously seen that if we take an element, say, for example, the element chlorine, and we look at the periodic table, we'll find that the numbers that chlorine has is this number 17, which we have learned is the atomic number. And on the bottom, we've got this number 35.5. And we learned that this number here is called the relative atomic mass. Relative atomic. And we previously calculated how we would work that out from the abundances of the different isotopes of this element and their masses. But what we're interested in today is to find out, well, why is it called the relative atomic mass? What is this idea about relative? Hopefully we understand that the atomic mass means the mass of an atom of this. That's what the atomic mass bit refers to, the mass of an atom of chlorine. But where does the word relative come from? We previously looked at an example where I asked was an object heavy, or does an object have a large mass? So imagine a brick. So does a brick have a large mass? And the answer is, well, it really depends. And it depends on what we're comparing it with. If I asked you if a brick has a large mass compared to a thumbtack, then yes, we would say the brick does have a large mass. Whereas if I said, does a brick have a large mass compared to an aeroplane, then no, it doesn't. It has a small mass. So it's all about having a scale to work from. So the relative atomic mass is not a real mass in kgs. This is not 35.5 kgs. It is not this. So what exactly is it? Well, it's kind of difficult to answer that. It's obviously the mass of an atom of this element relative to some reference point. That's why it's relative. So what exactly is it relative to? Well, to understand that, we need to look at an atom of carbon. Now, this is an atom of carbon. It's got 6 yellow dots here, and the yellow dots represent protons. It's got 6 purple dots, and they represent neutrons. And almost all of the atoms of carbon in the world are like this. So the abundance of this is what we call carbon 12. There are other isotopes of carbon, but this one is like the overwhelming majority, well over 90%, 90, I'm not sure the exact number, 97, 98% is like this. So we've got 6 protons and we've got 6 neutrons in an atom of carbon 12. Now, why are we talking about carbon? We're talking about carbon because when scientists first started measuring masses of different atoms and trying to figure it out, carbon is one that's easy to work with. It's stable, it doesn't break down, so scientists can work with it. And it's quite easy to measure the mass of. There's loads of carbon in the world. It's a very abundant element, so it's easy to get and it's easy to work with and it's cheap. So scientists use this to work around. Now, what we're talking about here is that we have 6 subatomic particles. So the mass of the atom of carbon really relies on the fact that you've got these 6 protons and 6 neutrons. So we've just learned that we have 6 protons and we have 6 neutrons. So the total mass of one of these atoms is going to be equal to 12 atomic mass units. 12 AMUs, atomic mass units. Now, the reference point, why is carbon relevant? Well, carbon is going to be the reference point which we compare all the other elements with. But before we actually figure out what should we compare it with, scientists figured out, well, if we were to take the mass of an atom of carbon and divide it by 12, so take 1/12 the mass of a carbon 12 atom, that would be exactly 1 atomic mass unit. Okay, because there's 12 atomic mass units due to 6 protons and 6 neutrons. So 1/12 of that mass would be exactly 1 AMU. What this means is that one of the neutrons has a mass of 1 AMU because it's 1/12 of a carbon 12 atom. And also one of the protons has a mass of 1 AMU because it's also 1/12 of a carbon 12 atom. Again, because there are 12 particles all together in the nucleus and it has a mass of 12 AMU, that means that any one of these has a mass of 1 AMU. And these are the reference points. 1/12 of the carbon-12 atom. This here, sorry, 1/12 of the carbon-12 atom. This is a reference point for all other atoms. Reference point for all other atoms. Which means that when we say that our chlorine atom, Cl, has a mass of 35.5, what that means is it's 35.5 times the mass of 1/12 of the carbon-12 atom. And this gives us this really complicated definition for what relative atomic mass is. This is it here. So relative atomic mass is the average mass of the atoms of an element. So this accounts for all of the different isotopes. That's why it's an average. Average mass of atoms of an element relative or based on or compared to 1/12 the mass of an atom of carbon-12. Now, it's really a pain, and it's not a definition I really like. But unfortunately, because this is the way scientists have figured it out, we have to appreciate the fact that this is what they did. So they took the mass of carbon-12, they took an atom of carbon-12, they found out what the mass of 1/12 of it was, because that's the mass of a proton or a neutron. And all other atoms contain protons or neutrons as well, so they must be some multiple of this mass, 1/12 the mass of a carbon-12 atom. I hope that makes sense. What I want you guys to do now is I want you to do this next set of questions in the answer booklet or in the question booklet that accompanies this lesson. Thank you guys. We'll see you in the next video.